Hey there, physical science. Today we're going to be looking at elements, compounds, and mixtures. How we classify matter into those three categories. There's many ways we can classify matter. These are just some of the ways we're going to do that. We're going to talk about what the differences between these things are. We can see there are many words we use to talk about matter. Here's some examples of them: elements, compounds, molecules, and mixtures. Um, Molecules is a little unique in there because it can refer to an element or a compound, but we'll talk about what those are. We're going to talk about the differences between them. You've got some skeletal notes to fill out. You've also got this little flow chart right here that can help you to be able to take some notes, write some things down, and have those with you to be able to um, having your notes, study, classify. Sometimes it just helps, not sometimes, all the time. It just helps to write things down. That's part of how our brains work to remember things. So we're going to start off looking at elements. Elements are the atoms that make up matter. An element cannot be broken down into any other substance. And so we have an example here in our picture. This is gold. It's represented on the periodic table by the letters AU, which is a little confusing, but it's represented by its Latin name, not its English name. AU is gold. Gold is an element, and it cannot be broken down into anything else. Once you break it down, we've been talking about the scientists with protons, electrons, neutrons. If you break gold down any further, you're getting down into those subatomic particles. The elements, when you think of elements, we want to think of atoms. They're the elements that make up everything that matter is, and they cannot be broken down into anything else. Here's a picture of the periodic table. Anything we see on this periodic table is going to be considered an element. If you see these letters combined, for instance, if you see an H and an O together, then that's not an element, that's a compound. We're going to look at that in a minute. But if you see a capital letter or a capital letter followed by a lowercase, and that's all that there is, then that's an element. It's the smallest kind of piece that makes up matter. When we think of it to Legos in your lab, you did those with Legos, this would be like one Lego piece by itself would be an element. If we had other colors attached to it, then we're no longer classifying that as an element. We also have compounds. Compounds are when two or more elements, two or more different elements have chemically combined and through a chemical reaction to form a new substance. This is represented by a formula. That formula is the combination of the element symbols. So in here you have NaCl. NaCl is sodium chloride, or that's table salt. And so that NaCl tells us the formula for table salt. You can see up here in the left-hand corner, we've got NaCl showing kind of what the molecule looks like. And we'll talk about that in a minute. But it's when they chemically combine and they form a new substance. And so, for instance, sodium by itself can be deadly. Chloride by itself can be deadly. When you put them together, they form something totally new called table salt. We can see here like at least how many elements are needed to create a compound. If you see that question, the answer is going to be at least two different elements. Right? And so they have to be two or more, and they have to be different. Just make sure you kind of write that down, get that in your mind. Chemically combined, and so they form a new substance through a chemical reaction. And if we wanted to separate them, we would need another chemical reaction to be able to separate them. They won't just separate kind of on their own or easily, is a lot of times how you'll hear the word used. Here's another example of a chemical formula. This one's Na2O, and we'll get in the future, we're going to be talking about what these numbers mean and how we figure all that out. But for right now, what I want you to know and remember is how to count the elements in a compound, um, you're looking for capital letters. All right. And so over here it tells us a compound will always have at least two elements, and we're looking for the capital letters. And so in this case, we have Na. The N is capital, the A is lowercase. So for what we're doing right now, we're not that worried about the A. And over here, the O is capital. So we know we have two elements here. So as we're counting those letters, we have two different elements, and so we know that's a compound. So that's what we need to be able to know here. How many elements are shown? We've got two different ones. Right now, we're not too worried about the numbers. We're just looking for how many different elements are there. If there's two or more different ones, it's a compound. So make sure you write that down, two or more different atoms or elements. And so when we go back and we're looking at our Lego bricks, these would be examples if we wanted to show a compound with Lego bricks. Notice they're connected together and they're different colors. And so each one represents different compounds. And so like this would be one compound, this would be another compound, this would be another compound. And this would actually be what we would call a mixture of compounds. And we'll talk about mixtures here in a moment. But looking at each one of these individually, we see we've got multiple colored bricks and they're all connected together, representing that they've bonded as one new substance. When we look at molecules, a molecule can be considered an element or it can be considered a compound. And so that's where it gets a little bit confusing. A molecule is any two or more atoms bonded together. If they're the same type of atom or the same element, then that would still be considered an element. And so, for example, O2, that's how oxygen naturally appears in our atmosphere. We don't find one oxygen by itself. It's always connected to another one. If you see this little number, then it's both an element and a molecule. If they're different elements, then it's, for example, H2O. So we have hydrogen and oxygen that are bonded together. That's a molecule of water, but it's also a compound because they're two different elements. And so when you're looking at molecules, molecules can kind of be either one. A molecule is the smallest unit that keeps the chemical properties of that compound. And so if you break down H2O any further, you no longer have water. So that's what that means. Molecules are the unit that keeps the chemical properties of that compound. And so here we have a water molecule that would also be a compound. So those words, that molecule is one that really can refer to a couple of different things, but what it's referring to is how that that compound or that element appears in nature. If we break it any further down, it becomes something different. So if you see this question, what is the smallest unit of a compound that keeps its chemical properties? The answer is molecule. So make sure you write those down in your notes and the differences between those different things. You don't have molecule in your flow chart. It's a write down, but on your notes, make sure you're filling in the blanks, know what those are. All right, so here's an example. Both of these would be considered molecules. For looking at Lego bricks, if it's the same brick, connect it together, it would also be an element. It's a molecule because there's two or more connected together. It's an element because they're the same type that's there. Or it's a compound when there's two or more connected together, but they're different. Either one of those would be considered a molecule. And then last, we're going to talk about mixtures. Mixture are when two or more atoms, elements, or compounds close together but not bonded together. And so they haven't had a chemical reaction. They're not permanently together. It's a physical combination of materials. The parts of the mixture aren't changed by being in the mixture. There's no chemical bonding. And I'll give you some examples of this in a minute. Typically, mixtures are easily separated. And so if you've ever opened a bag of frozen mixed vegetables, that has the peas and the carrots and the green beans and whatever corn, whatever else is in there, those things are all individually in there, but they're mixed together. Another example would be like trail mix. And so they're in the bag together, but they're not chemically combined. They don't make something new. They're just all mixed in together. Um, and so we're going to look at two types of mixtures in just a second, and then we'll expand on those in lessons to come. But they're easily separated, meaning you could pick all the peas out of the mixed vegetables if you don't like. I don't like peas, and so I'd pick those out, right? In trail mix, I don't like raisins, so I don't eat the raisins most of the time. I just eat the peanuts and the M&Ms or pretzels or chocolate chips or whatever else is in there, and I leave the raisins out. They're easily separated. Some are really easy to see how they're easily separated. Others are not as easy to see, but it will explain what some of those things are. And so here's using our Legos. This would be an example of a mixture. Notice that they are not combined together. The bricks are not put together in any way. They're just kind of in a pile, all mixed in. So this might be, if you played with Legos growing up, this might be just when you threw them all back in the box or the bag or wherever you kept them. That would be a mixture. And so we've got two different types of mixtures. We're going to start with heterogeneous. We know the prefix. We already know this prefix. We just use it in a different context most of the time. But hetero just means different. And so if you see that prefix on something, it means that it's different. And so a heterogeneous mixture means that it's different throughout. And so example would be mixed vegetables or trail mix. When you grab a handful of trail mix, there's no guarantee that you're going to have the same number of M&Ms and peanuts and raisins and pretzels or whatever you have in there. It's going to be different amounts with each handful you grab. It's really, really easily separated, right? You could just pick them through physically. So examples of a heterogeneous mixture would be trail mix, mixed vegetables, different colored Skittles or M&Ms. Those would all that group of Legos in the picture we just looked at, those would all be heterogeneous. They're not consistently the same anywhere you take a sample. The other group is called homogeneous or homogeneous. That's the correct pronunciation, but homogeneous kind of helps you remember. All right. The prefix homo means same. And so again, we already know what these prefixes mean. We're just not thinking about what they mean most of the time. And so it means same. These mixtures are the same throughout. And so examples would be solutions, which we're going to talk about a little bit more. But like chocolate milk would be a homogeneous mixture. Now, there's no chemical reaction that takes place with chocolate milk. So it's not a compound. Make sure you understand the difference. And this is where this flow chart is really helpful for you. Homogeneous mixtures are mixtures. Even though they're the same throughout, it does not make them a compound. They are still mixtures. So chocolate milk, if you've ever let just chocolate milk sit for a while, the chocolate and the milk will start to separate from each other. In fact, milk itself is a really well-mixed homogeneous mixture. It'll begin to separate into the fatty parts and the liquid if it sits long enough. Salt water is a homogeneous mixture. You could take salt water and boil the water, and the salt will be left behind. It hasn't become a new substance. Boiling is not a chemical change. We talked about phase changes or physical changes, and so no chemical reaction has taken place. You could just boil the water would leave, the salt would be left behind. Sweet tea, another example of a well-mixed homogeneous mixture. And so we're going to talk more about mixtures and solutions and how to separate mixtures in an upcoming lesson. But for right now, you need to know what's the difference between a heterogeneous mixture and what are some examples. and a homogeneous mixture, and what are some examples? One last slide, just some things for you to think through. I want you to imagine that you've gone to the beach and spent a day at the beach, and you have a bucket of shells and sand and salt water, and you just take it back up to wherever you're staying and you leave it on the patio or the balcony or the steps there. Um, when you go back and you gather the shells from the bucket a few days later, you notice that all the water is gone and there are white crystals on the bucket. And so think about for a minute what happened. Maybe talk as a class. What do you think happened to the water? And why are those white crystals left behind? And then think about this. Was the salt water there? Was it a compound or a mixture? Remember, compounds require a chemical reaction to separate. Mixtures only require a physical change to separate. What about the sand, shells, and water? What happened to those things? Are those compounds or mixtures? What do you think? And then how do you know the answers to those things? All right, and so you've got in your packet of stuff there, you've got this notes here, you've got your skeletal notes, and then you've got two different worksheets that you're going to work on. One is this one, all right, that's the elements, compounds, and mixtures worksheet. And then the other one is this one right here. You also have Discovery Ed that you can go back through, look through, make sure you get the answers to these on that as you're going. And so maybe you had this during the lecture, maybe you're just getting it now, but you can go on Discovery Ed and find those answers. And so hopefully this was helpful. If you have any questions, please let your teacher know, and they will help you work through those things. And we'll continue to talk about mixtures a little bit more in days to come. Have a great day.